All right, so I think this is recording. Let's take a look at problem number 5. It's got several parts to it. And in number 5, it gives us two functions, f and g. And for parts a and b, it asks us to find the domain of f and the domain of g. So whenever you're finding the domain of the function, the idea is always the same, that the domain is a set of all real numbers, excluding any values that would cause division by 0, and also excluding any values that would cause us to take the square root or even root of a negative number. So for both of these functions, I don't have to worry about taking the square root of a negative number because there are no radicals. But for f, I do have a variable and a denominator, but for g, I don't even have to worry about division by 0 because in g, I do not have a variable that appears in a denominator. So the first thing I want to do when I'm doing part A for f is to factor that denominator because I'm concerned about if this denominator would ever equal 0 because it's got a variable there. Well, two numbers that multiply together to give me negative 20, but add together to give me a negative 8 are negative 10 and positive 2. With a leading coefficient of 1, the x method is very nice and stuff, but you can more or less do it in your head when that leading coefficient is 1. So now it's very easy for me to see that I need to avoid the number negative 2 because negative 2 plus positive 2 would give me a 0 in the denominator. I need to avoid the number positive 10 for that same reason, that 10 minus 10 is 0, and any 0 times anything is 0, and that gives me a 0 in the denominator. So for the domain of f, it's the set of all real numbers, excluding negative 2 and excluding positive 10. All of the other real numbers, they do not cause division by 0, so they are in the domain. Pick any number you'd like in the shaded region and substitute that number in for x into the function, and you would find its corresponding y value. So the domain for this function f is from negative infinity to negative 2, excluding negative 2, from negative 2 to positive 10, excluding positive 10, and from 10 to infinity. So there's the domain for part A. All right, so let's take a look at part B. And I do have more parts, so I'm going to try to delete this and then shrink this and move this up because I may need this. I know I'll need this to help me with the later parts of this problem. All right. So when we look at G, like I said before, the domain is a set of all real numbers excluding any values that cause division by 0. Don't have to worry about that. Also excluding any values that take the square root or even root of a negative number. I don't have to worry about that because there's no variable in the denominator and there's no variable that's underneath the square root. So the domain for this function G is all real numbers. So now, in part C, it asks to find the domain of this function composition f composed with g. So these function compositions, I like to think of them as like an assembly line. And even though f is listed first here, we actually start with the function g. We take a value from g's domain and we substitute it in. We evaluate g at this x, and then we take the output of g and it becomes the input for f, And the output that we get is f of g of x. Just another way to write this fog in function notation. So two things have to be true to be in the domain of this f composed with g. The first thing is that x has to be in the domain of g. And the second thing is the output of g, this g of x, has to be in the domain of f. Well, g is not very picky at all. G has a domain of all real numbers. So there's absolutely no problem with g. It doesn't cause us any restrictions. So we need to look and see if the restrictions will come from this function f. So what is g of x? Well, g of x is 2x plus 6. And the one thing that we have to avoid for f is we cannot have an input of -2. So I have to figure out the value of x that would cause this expression to equal -2 and then avoid letting that happen. So I temporarily let this function equal -2, this equation equal -2. So 2x is equal to -8. So x is equal to -4. But because g evaluated at -4 gives us a -2, and f at -2 is undefined, we can't let x be equal to -4. We have to throw -4 out of the domain. The other thing that has to be true is that this 2x plus 6, we have to avoid letting it have a result of 10. So we temporarily let it equal 10 just so we can know what x value to avoid. X equals 2. If x equals 2, then g evaluated at 2 will equal 10. And we can't let that happen because f evaluated at 10 is undefined. So we throw 2 out of the domain. So our answer here for this one, for the domain of f composed with g, it's the set of all real numbers excluding the numbers -4 and +2. This is what we need to exclude right here. And writing that in interval notation from -infinity up to -4, excluding -4 all the way up to 2, and excluding 2, I need to shrink this up. Excluding 2, and then going to infinity. This is the interval notation for the set of all real numbers, excluding -4 and also excluding +2, and that's our answer for the domain of f composed with g. Oops. So here's our answer for part C. In the last thing that this problem is asking us for is to find the domain of golf, G composed with F. So this time when we think about how this function is built, it's built from the functions f and g. And notice that just like last time, I don't actually have to find the expression of this new function to find its domain because I know how it was constructed. I know how it was built. The first, I think of this like an assembly line. And the first function is f. And so we give f some input, and then we get some output. The output of f becomes the input for g. This is the reason that I refer to it as an assembly line. It just happens in sequential order. And we can have a whole list of functions here, but we've only been looking at it when it has a length of 2 functions. That illustrates the idea is fine for us for right now. All right, so 2 things have to be true to be in the domain of this g composed with f. The first thing is that the number has to be in the domain of f. And the second thing is the output of f, since it's becoming the input for g, the output of f has to be in the domain of g. So remember that g was very easygoing function. It doesn't exclude any values. The domain of g is all real numbers. So anything that f produces, it's going to go through this function g with no problem. So the domain for this function g composed with f is simply the domain of f, which was all real numbers, excluding the -2 and +10 that caused division by 0. So it happens to be the same answer as our answer in part A. All right, so I hope that helps. If you have any questions, ask. If you've noticed anything that you think that I have factored wrong or done something silly in this video, please let me know. I hope this helps, and I will talk to you later. Bye.